After the workspace settings have saved, select GLM Model Construct from this drop-down menu and choose Gambling Problems Lifetime Workspace because we are working with the multiplicative model. A GLM is a mathematical model of how the predictor variables and the response variable relate to each other. It's like an advanced form of linear regression. We can depict a GLM graphically like this, so we don't need to get into the maths too much if we don't want to. There may be complex multivariate relationships that looking at each variable at a time would miss, or double count. The resulting model's predictiveness should generalize to future examples outside this dataset. You might be building the model on past data to predict the future, or on a sample of data to predict the whole population. The modeling approach we take is the same in either case. I'll refer to using sample data to generalize about the population, but you could just as easily think about it as using past data to generalize about the future. We want to build a model on our sample that achieves a good compromise between fitting the sample data well, since the sample is normally reflective of the population, but without fitting to noise in the sample data. Noise is random variation specific to the sample that we happen to collect that is not representative of the whole population. We want to find a good model that is as simple as possible without systematically under or overfitting segments of the sample data. We do this by ensuring only statistically significant parameters are kept in the model, simplifying and modifying variables as we go along by grouping categorical variables and fitting splines to continuous variables, and then using machine learning to mine the model residuals and point us in helpful directions. In the GLM construct page, choose your dataset, choose the workspace from the dataset that you're interested in modeling, and then begin modeling from there. If you ever forget what the settings for the workspace were, you can just go back to the workspace settings page and take a look, and then come back to GLM model construct. The predictors are along the left hand side here, and the chart is in the middle. Let's look at the gender predictor by clicking on it and talk through the chart. The grey bars show the weighted number of records for each level. The right axis values refer to the grey columns. Weighting each record or each case by the sample weight variable we chose earlier, there are 1,390 males and 1,476 females. Note that the right axis in this case doesn't start at 0. Categorical variables like gender are split based on what was in your original file that you uploaded. Get a quick sense for one-way relationships between each predictor and response from the red line. The red line is one way in the sense that this is what you would see if you summarized the average gambling problem score by gender without taking into account other factors at the same time. Males have a higher gambling problem score than females. The response variable, such as gambling score, is always rebased to 1 for the category with the biggest sample size count, or biggest case count. In this case, it's females. Note how the red line, or the red point, is 1 for females, however it's 1.84 for males. This indicates that the gambling problem score for males is 84% higher than it is for females. If all we were interested in was each one-way relationship between the predictors and the response, then we could stop here. But this would be very misleading because the predictor variables might be correlated with each other. So let's look at highest grade attended. The categories are the individual finished in 1st through 8th grade, 9th through 11th grade, 12th grade, technical school, 1 through 3 years of college, 4 years of college, and continued on to graduate and professional school, and that they refused to answer the question. Now, the majority of respondents fall into the 1 through 3 years of college bracket, with 807 respondents on a weighted basis. Now, the points on the red line for the other brackets are the gambling problem score, all expressed relative to the 1 through 3 years of college level. Note how, for any of these charts that you could look at, The red line is always 1 for the category with the biggest grey bar, and then all other points on the red line are expressed relative to that level of 1. Now those who only completed 12th grade have a gambling problem score 32% higher, 1.32, than those who completed 1 through 3 years of college. What we're looking at here are just summary statistics. We haven't built a model yet at all. Those who completed 9th through 11th grade have a problem gambling score 67% higher than the base level, and those who completed 1st through to 8th grade are 16% higher. Does this mean that not going to college increases gambling problems later in life, or going back to the earlier example, that being male tends to lead to gambling problems? Based on the summary statistics we have just looked at, this is the suggestion, but it can get very complex with mediating and moderating effects abounding.